Hello everybody, hope all of you are doing well. Today the purpose of making this video is to spread an awareness regarding the importance of uranium. Yeah, of course you must have heard uranium, it is very economic, but most of the times people are afraid of discussing about uranium. So it is my simple duty to spread awareness. Uranium is not that much harmful, whatever myth is spreaded in the society. So it is blessing in disguise. So we must know the importance of uranium. Uranium is very much economic. It is strategic element. It is 92. It's atomic number. So stable element is uranium. So it is very important from global warming point of view as well, because nowadays using fossil fuel, that CO2 emission creates problem. So to get rid of those problems, uranium is essential. Sooner or later it has to be utilized. So let's start. I'll first give a brief idea about uranium, its importance from energy point of view, and just simply I'll make a comparative study how uranium is important, because 1 gram of uranium you will see it is equivalent to how much ton of fossil fuel like coal or natural gas or that oil. Those things I'll discuss. So here for a comparison I am showing a table. You can compare different fuel type and corresponding energy production. If you see dry firewood, 16 megajoule per kg energy is produced. From lignite brown coal, 10 megajoule from per kg. Then black coal of low quality, 13 to 23 megajoule million joule. Then if we see that hard black coal, 24 to 30 mg per kg, natural gas 38 mg per kg. From crude oil you can get 45 to 46 mg per kg. Now coming to uranium in a typical reactor, simple uranium, from per kg how much energy is produced? See, 5 lakh mg per kg. Okay, so now if you compare how much times it is produced from uranium, you can easily calculate. With time, the primary energy consumption has been increasing due to booming population and modern lifestyle. These have a dramatic impact on energy demand. Energy is of two types, primary and secondary. So primary comprises of natural resources like oil, natural gas, wood, coal, solar, wind, hydropower, etc. Whereas the secondary one is usable forms. And uranium belongs to which category? It is perhaps belongs to secondary, but it is reusable but limited extent. Okay, all fossil fuels like coal, oil, natural gas together provide about 80% our energy supply. To answer this basic question whether uranium is renewable or non-renewable or primary or secondary source, the answer is quite tricky, because present technology and scientific scenario assign uranium as a sustainable but long-lasting economic energy source. However, even it could become a completely renewable as well if the extraction criteria and techniques are improved in future. Thus, if uranium source is possibly targeted in future from mined ores or sea water, that is more economic if technology is supportive, then it will become a renewable source as well in future. So now we will see how much energy can be generated from 1 gram of uranium, because still uranium is a huge energy source at present as well. This is because single atom of 92U235, for example, okay, it is fissile, automatically it can be fissioned and it can give around 200 MeV, million electron volt. Okay, this much energy can be generated from one atom. one atom of 92U235. Okay, one atom. So therefore I would like to explain how much energy can be generated from 1 gram of uranium, 1 gram of simple uranium. So if we consider natural availabilities of 3 uranium isotopes which are most pronounced, most commonly observed, that is 92U238, it is around 99.27%. okay, then 92U235, it is 0.72, approximately 0.72 0.7%, okay, round up. And 92U234, it is very less, almost 0.005%. okay. Then also fission of 1 gram. Now fission of 1 gram, fission automatically it is breakdown, no? Now it is guided by N by P ratio, that is neutron by proton ratio. So fission of 1 gram of uranium can give 200 MeV. So within 1 gram, how many atoms is present? Okay, so 92U235, its percentage is 0.7%. So within natural 1 gram of natural uranium, 92U235, how much? It is 0.007 gram. Correct? Because percentage is same. Natural uranium of 1 gram, within that 92U235 specifically will be present this much only, 0.007 gram. Now from atomic number it can be analyzed that 235 gram of uranium 235 comprises Avogadro number, that is 6.023 into 10 to the power 23, this many atoms. Okay, correct na? So 0.007 gram of 92U235 comprises how many atoms? First it has to be determined, correct? Avogadro number, it's a simple mathematics. From this it can be calculated that 0.007 gram of U235 comprises around 0.18, you can calculate by using calculator as well, into 10 to the power 20 numbers of atom. So these multiplied by 200 MeV, as already I have shown. One atom generate 200, so this many atoms, 200 multiplied by 0.18 into 10 to the power 23, this much MeV, na? So this is coming around 3.6 into 10 to the power 21 MeV. So this much energy can be generated from 1 gram of natural uranium. Now as we know, 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. So 1 MeV equal to naturally 1.6 into 10 to the power minus 19 into 10 to the power 6. 1.6 into, very simple legible way I am trying to show, 10 to the power minus 13. 1 MeV, this much joules. So as I already we have derived that 1 gram of, from 1 gram of natural uranium, 3.6 into 10 to the power 21 MeV energy can be produced. So if you convert it into joule, it is multiplied by 1.6, it is multiplied by 1.6 into 10 to the power minus 13. So this much MeV means this much into this much MeV means this into this joule. So 3.6 into 1.6 into 10 to the power 8. Okay, now if you calculate, it is 5.76 into 10 to the power 8 joule. So in terms of joule, 1 gram of uranium, natural uranium of course, can produce 5.76 joule. Now as I have shown from that table earlier, as per this table earlier I have shown, 5 into 10 to the power 5. 5 into 10 to the power 5 mg. That is 5 into 10 to the power mg means 5. So from as per this table, from 1 kg 5 lakhs, 5 into 10 to the power 5 megajoule. Mega means 10 to the power 6. So 5 into 10 to the power 11 joule per kg. That means 5 into 10 to the power 8 joule per gram. And our estimation also have come something like similar, 5.76. So that's it. So finally we can easily understand that natural uranium is a significant energy source if you compare to any of the other sources of energy. There is no comparison, no competition. It is unparalleled. Uranium is one and only source which can give an enormous energy.